Okay, so let's talk about something. We've got one more new vocabulary word here. We've talked about the dot product. That's new and exclusive to vectors. Let's talk about what we call orthogonal vectors. Orthogonal. Now, orthogonal is just the vector application word of perpendicular. Okay, orthogonal is just the vector application version of perpendicular. It means the same thing. Okay, so the vectors u and v are orthogonal or perpendicular if and only if the dot product of u and v is 0. Now let's think about this for a second. Why is that true? If two things are perpendicular, what does that mean? What does it mean if two things are perpendicular? They form a 90-degree angle, a right angle. Okay, so we just talked about finding the angle between two vectors. We said that the angle between two vectors is the cosine of that angle is equal to that fraction right there. Well, we're saying that they're perpendicular, so there's a right angle. So theta is 90. What's the cosine of 90 equal to? 0. The cosine of 90 is equal to 0. We've got a fraction that has to equal 0. The only way a fraction will equal 0 is if the numerator equals 0, right? If the denominator equals 0, we're undefined. So the numerator has to equal 0. Well, what's in the numerator? The dot product. Okay, so that's why this is a true statement. They are orthogonal if and only if the dot product equals 0. Now, if they're not orthogonal and they don't have a certain angle in between them, we can also talk about them being parallel. Well, think about your vectors for a second. When we draw them, they're kind of like line segments, right? So line segments, parallel lines have the same slope, right? So we can kind of sort of figure out the slope of these things, right? Slope is y over x, or the j over the I, if we're talking specifically about vectors. So those are the two things that we're going to check if the question is, are they orthogonal, parallel, or neither? So if they're orthogonal, the dot product's going to equal 0. If they're parallel, their y component over their x component is going to be the same, or it could just be the opposite, okay? Because vectors have direction, so a slope of positive 2 and a slope of negative 2, technically those are parallel vectors. One's just headed in the other direction from the other one. And neither is obviously if neither one of those two things apply. So let's check that first example there. The vector 2, negative 3, and 6, 4. We want to see if it's orthogonal, so we find the dot product. 2 times 6 plus negative 3 times 4. We get 12 minus 12, so it's 0. So those two are orthogonal because the dot product was 0. All right, let's look at B. Let's find the dot product. Negative 4 times 12 plus 6 times negative 18. That's negative 48, and I don't know what 6 times 18 is without using my calculator, but I know it's not positive 48, right? So I know they're not orthogonal. So the next question is, are they parallel? Let's do the slope of u, the y component over the x component. So that simplifies to negative 3 over 2. The slope of v, the y component over the x component, those are both divisible by 6. Negative 3 over 2. Same slopes, so these are parallel. It would have also worked if one of these was negative 3 over 2. It's just headed in the opposite direction, but it has the same slope. Okay, so this is just slightly different than true parallel lines because these vectors have direction to them. So you could have a positive and a negative and they still be parallel as long as they're the same number. Okay. Do that practice problem and then you can do the rest of the problems there